Hello students, so in this video we are going to discuss about how to calculate average velocity and instantaneous velocity. In the previous video we had seen what is the basic difference between average velocity and instantaneous velocity. Now we will solve the sums based on these concepts, average velocity and instantaneous velocity. Also we had seen the formulas of differentiation like d by dx of x raised to n, right, is equals to n times x raised to n minus 1. D by dx of constant, if it is only constant, so the differentiation of constant will always be 0, right, and d by dx of say kx square, where k is any constant, so it has to be taken outside, and then d by dx of x square, you have to differentiate x square, so it is finally 2kx. So these are the three formulas, basics formulas of differentiation which we had discussed in the previous video. Okay, fine. Now let us solve 2-3 questions based on the concept of average velocity and instantaneous velocity, right? Okay, so the question is, position of a particle x is equals to t cube plus 4t square minus 2t plus 5. That means position of the object changes with respect to time. You have to find the velocity during the time interval 0 to 4 seconds and also find the velocity at 4 seconds. See, we had already discussed that when 2 interval of time is given in the question, that means that will give you average velocity. And at a particular instant of time, if you are being said to calculate velocity at a particular instant of time, that means you have to calculate instantaneous velocity, right? So, in this particular question, you have been said to calculate average velocity and also to calculate instantaneous velocity, right? Okay. Never differentiate to calculate average velocity, right? Make it very clear. Whenever you need to find average velocity, don't differentiate. When you have to calculate instantaneous velocity, always go for differentiation, right? Okay, so what is the definition of average velocity? Final position minus initial position upon time, right? Okay, so by substituting t equals to 4 in this equation, you will have final position. By substituting t equals to 0, you will have initial position, right? So final position of an object is equals to x of 4, which is equals to 4 cube plus 4 into 4 square minus 2 into 4 plus 5. This will give the final position of an object, right? So this is 64 plus 64 minus 8 plus 5. So it is 128 minus 8, 120 plus 5. So final position is 125, okay? Initial position will be obtained by substituting t equals to 0 in the same equation. So if you are substituting t equals to 0, this term will be 0, this term will be 0, this term will be 0. So your remaining term will be 5. So initial position is 5, final position is 125. So average velocity is final position minus initial position. So that is 125 minus 5 upon, what is the time interval? 4 to 0, that means 4. So it is 120 divided by 4. So your average velocity comes out to be 30 meter per second. This is how you will find the average velocity. Don't differentiate the position in order to calculate average velocity, right? Substitute 2 different interval of time, find the initial and final position, subtract it, and you can calculate average velocity, right? Okay. Now you have been also said to find velocity at 4 seconds. So this is instantaneous velocity at a particular instant of time, right? So in the previous video, we have seen that instantaneous velocity is dx by dt, differentiation of x with respect to time, right? Or d by dt of x. So velocity at t equals to 4 seconds will be obtained as dx by dt equals to v. So differentiate the term, that means this is how you can write d by dt of x. So that is t cube plus 4t square minus 2t plus 5. So separate this d by dt of t cube plus 4 times d by dt of t square minus 2 times d by dt of t plus 5 times, sorry, 5 is constant, so constant, the differentiation of constant term, only constant term will be 0. So dx by dt will give you velocity. Now use the formula d by dx of x raised to n, right? It is n times x raised to n minus 1. So compare your formula with this basic formula. It is d by dt of t raised to 3. So it is 3 t raised to 3 minus 1. So that is 2. Clear? Plus 2 into 4, 8 t raised to 2 minus 1. So that is 1. It is d by dt of t raised to 1. So 1 will come here and t raised to 1 minus 1. So that is 0. So anything raised to 0 is always 1. Right? So velocity is 3t square plus 8t minus 2. Substitute t equals to 4. So it is 3 into 4 square plus 8 into 4 minus 2. Right? So it is 16, 3, 48 plus 32 minus 2. So this comes out to be 78. So this is the instantaneous velocity at t equals to 4 seconds. Right? So the basic difference in calculating average and instantaneous velocity is, whenever you are supposed to calculate average velocity, do not differentiate the position of the particle, right? And if you are being said to calculate instantaneous velocity, always go for differentiation. Clear? Now we will see one more example based on the same concept. So in this question, position of the particle x of t is equals to 4.2 t square plus 2.6. Again, the position of a particle changes with respect to time, which is 4.2 t square plus 2.6. We are being said to calculate velocity from 0 to 3 seconds, and you have to also find velocity at t equals to 3 seconds, right? So calculating velocity from 0 to 3 seconds, that is the average velocity, and velocity at 3 seconds, so that is instantaneous velocity, right? So for calculating this velocity, we will not differentiate, and while calculating this velocity, we will definitely differentiate, right? So first of all, let us find the velocity from 0 to 3 seconds. So substitute t equals to 0, this will give me the initial position. So it is equals to 2.6, right? Substitute t equals to 3 seconds. That will give me the final position, which is 4.2 into 3 square plus 2.6. 9 into 4.2, 40.4. So this is the final position, this is the initial position, right? So average velocity will be final position minus initial position upon time. So it is 40.4 minus 2.6 divided by 3. Is nearly 12.6. So this is a average velocity. Now you are being said to calculate velocity at 3 seconds, right? So that is instantaneous velocity. So according to the question, it is 4.2 t square plus 2.6, right? Differentiated dx by dt. 4.2 is constant. Differentiation of t square will be 2t plus differentiation of 2.6 will be 0. So it is finally 8.4 into t. But what is t? 3. So 8.4 into 3. That is 25.2. So this is how we will calculate instantaneous velocity, and this is how we will calculate average velocity. Right? Okay. So now in the next lecture, next video, we will discuss about acceleration, average acceleration, right? And how to calculate acceleration from position of the particle or velocity of the particle, and we will also see the graph of velocity time. Clear?